Alright, this is section 3-4, part 2 in advanced geometry. Today, a lot about horizontal and vertical lines and something extra special. But just to refresh our memory, the horizontal line in this picture is our red line right here, and the vertical line is our blue line. And what we did last time was write equations of oblique lines. Oblique lines in their equations have both an x and a y in it. But here, all of a sudden, a bunch of ordered pairs show up on these horizontal and vertical lines. The reason why we've always called them horizontal lines is because the only variable in their equation is y. And you can see this red line's equation is y equals 6 because every ordered pair on that line has a y value of 6, right? And the slope is 0 because you'd rise 0 and run however many you want to. So every horizontal line's equation only has a y in it. And when you go to a vertical line, all of these x values are 4, so that's why the equation of that vertical line is x equals 4 in this particular case. And the slope is undefined because you end up running 0. Like if you rise 1, 2, 3 and run 0, rise 1, 2, 3, 4, 5 and run 0, you can't have 0 in the denominator, so that's why the slopes are undefined. So on our practice worksheet, these first 12 questions are just money questions because there's really no work to be shown. It says write the equation of the line given the following information. It's supposed to be a horizontal line going through this point. Since it's horizontal, we know its equation is only going to have a y in it, and it's got to go through this point, so we care about the y value of that point. In this case, since we're going horizontal, that guy's equation is y equals 5. And its slope is 0, right? Every horizontal line has the same slope of 0, but the equation is y equals 5. Here on number 2, they want the equation of a vertical line, so you know since it's vertical, it's only going to have one variable, x, and since the line goes through this particular point, that x value will be 9, which is the x value of the point that they gave me. So again, vertical line means x equals, and the point that they want me to go through, that's the x-coordinate. And a horizontal line, got to be a y only, and it's going to go through 2 in this, so y equals 2. Then parallel to this line right here, well, this line right here is horizontal. All horizontal lines are parallel to each other. They have the same slope of 0. So if I want to be parallel to this line, then I will write another horizontal line's equation. But they want me to go through this point in particular, so y has to be 4. And again, parallel is the magic P word they give me. They want me to be parallel to this guy. That's a vertical line, so I will need another vertical line's equation, x equals, and I got to go through this ordered pair, so x equals 5. But then they switch up the P word on me. They say we want to be perpendicular to this line right here, which is vertical. So if I want to be perpendicular to a vertical line, I need a horizontal line's equation. So that will be y equals -3 in this case for me to go through this particular point. Try number 8. Perpendicular to y equals 14, but going through 0, 5. So since this is a horizontal line, and we want to be perpendicular to it, I want a vertical line's equation, and I want to go through the point 0, 5, so x will equal 0. And then these, looks like we got to find the slope and do all that cool stuff. Not really. If you look at the ordered pairs, the first question I ask myself is, are the x-coordinates the same? They are. That means that we could stop right there and say x equals 1, because that's going to be a vertical line. We did this in class. We realized what type of line it was, and its slope is undefined. Like, all that stuff can be told without even doing the work. Like, if we was to find the slope, we do 9 minus 5 over 1 minus 1, which gives us 4 over 0, which is undefined. Right? We can tell all that just by looking at the ordered pairs because the x values are the same. We know that that equation is going to be x equals 1. It's a vertical line with an undefined slope. On number 10, x values are not the same, but the y values are. So we know that this equation is going to be y equals 2. And that's going to be a horizontal line with a slope of 0. Every horizontal line has the same slope of 0. So why don't you try 11 and 12 on your own. Give the video a pause and get 11 and 12 done. On 11, you should have got y equals 2. That's horizontal, and it's got a slope of 0. And on 12, both x values were the same, so that equation is x equals negative 20. And that's a vertical line with the slope being undefined. And if you get to 13, the x values are not the same. The y values are not the same. That means that this line is going to be oblique. So they want us to write the equation. We got to go through and do all of that cool work. We got to find the slope first. So let's get that done. And we get 4 over 1 for our slope. Then they want us to write the equation, so it will have both an x and a y in it, and we use point-slope form. I need a point. They give me 2 of them. I need a slope. I got it. So we'll do y minus y1 equals m times the quantity of x minus x1, where again, remember, x1 and y1 are the ordered pairs that they gave you, so it'll be y minus 5 equals the slope, which is 4, times x minus 2, and then we'll go through and simplify. That one came out real nice. Next one, not so nice. It's going to be ugly. But again, x's are not the same, y's are not the same. It's going to be oblique. Let's find the slope. 1 minus 6 over 5 minus a minus 2. So I got my slope to be negative 5 minus a minus 2, negative 5 sevenths. So then pick a point. It doesn't matter which one of these 2 points you want. So I'll do y minus 1 equals negative 5 sevenths times x minus 5. And now this isn't very pretty because this denominator is like, let me start over. This number right here is not a multiple of that denominator. So let's go through all the practice without a calculator. Remember what I told you about that ACT, how they take that calculator away from you. And all we got to do is distribute this. Remember, we want to figure out what sign this is going to turn out first. So negative times a negative is a positive. And then just make this guy a fraction. Right? To multiply fractions, you do not have to have a common denominator. You just multiply it. Numerator times numerator. 5 times 5 is 25. Denominator times denominator, 7. But when you want to add fractions, that's when you need the common denominator. So we all know we got to add 1 to get y all by itself, and it's going to get added to this green number. Instead of adding 1 to both sides, why don't we add 7 sevenths to both sides? Alright, so that way this guy and this guy has a common denominator. So those go away. Negative 5 sevenths x comes down, and 25 sevenths plus 7 sevenths is 32 sevenths. So it is not pretty, but that is the right answer. Let's now, on this one, find the midpoint of these 2 points. Right, so you got segment AB. Basically, these are the 2 endpoints. Here's that formula one more time. It's the actual formula that's on your cheat sheet this time. It's just an ordered pair, to where you're averaging the x's and you're averaging the y's. When you add 2 things together and divide by 2, you're finding the average. So here's the work that we'll show. We'll do midpoint equals, and that's important for what we're going to do on the back side to label our work. So what are we doing? We're finding a midpoint. And then the x values are 2 and 7. I'm going to throw them over 2. The y values are 8 and 10. I'm going to throw them over 2. And then we're just going to keep working down. That's a grouping symbol right here, so we do what's in the numerator first. Same thing here. And we just, sorry, I should have brought my equal sign down. And we just keep on rolling. I don't like decimals. I don't like compound fractions, so that's what we got right there. 9 halves just stays 9 halves, and 18 divided by 2 is 9. That's the midpoint. Why don't you try this one? Midpoint equals x's. You need to add together, and since you're adding a negative, it turns into subtraction. Just like so. Keep the -1/2 a -1/2. 8 over 2 becomes a 4. So this is going to help us on the backside, but before we get to the backside, let me kind of explain what it's all about. We're going to write the equation of what's called a perpendicular bisector. Here's a segment. Let's call it segment AB right here. It is a horizontal segment, and hopefully you could have told that without me even graphing it if the 2 points were 2, 3, and 8, 3 aren't the y values the same, right? So that's going to be a horizontal segment. Well, let's find the midpoint of this segment just for fun, because that's what we've got to kind of do on the back side. The midpoint would be 2 plus 8, you can just watch, and 3 plus 3 over 2, which turns into 10 over 2, which is 5, which turns into 6 over 2, which is 3, 5, 3, boom, let's call this M for midpoint. M, this point right here is smack dab in the middle of those 2 points. Now if I was to draw any line through there, like let's say that green line right there, it went through that midpoint. What that did was it totally cut that segment into two equal pieces. That green segment and that blue segment are totally the same. And when something cuts a guy into two equal pieces mathematically, it's got a fancy name. That's called a bisector. But that green line was just any old green line. What if I drew this green line? Since this is a vertical line and this segment was horizontal, would you believe that those guys are perpendicular to each other? So what we're going to do is we're going to write the equation of what's called the perpendicular bisector. Not only does that green line bisect, it cuts this segment into two equal pieces. It goes through it at a 90. That's what's called a perpendicular bisector. You see this black line right here, it just bisects that segment. It didn't go through it at a 90. So there's bisecting and perpendicular bisecting. We're going to write the equation of the perpendicular bisector. Now I know underneath this graph here on your paper, you've got all the steps, which is good. You need to do the steps in that order. But what I want to do is actually show you what is happening when we're doing this perpendicular bisector stuff. Because many times kids are like, I don't understand what we're doing. It's like, I just don't see what's going on here. So I'm going to show you what's going on. So here's the question. This is on the back side. Write the equation of the perpendicular bisector of segment AB. Notice I have segment AB. If A is located at 1, 3, which is plotted, and B is located at 7, 11, which is plotted. So here's actually where segment AB is. Notice it's oblique. The x's were not the same and the y's were not the same. So step 1, according to your steps right here, says find the slope. So let's keep ourselves nice and organized and make sure you do m equals. Let's find the slope of segment AB. So that'd be y2 minus y1, x2 minus x1. 11 minus 3 is 8. Over 6, that's not good enough. We want to reduce. Slope of this segment 4/3. So I'd rise 4, run 3, rise 4, run 3. Right? Slope of that segment definitely 4/3. But check it out. Here's what we're looking for. Let me kind of just draw you an idea of it. We're looking for the equation of the perpendicular bisector of that segment. So here, this green line, I just kind of put it in place. I don't know if that's right or wrong, but this green line, I want to write the equation of the line that's perpendicular to this red segment and goes through the midpoint, right? So it gets bisected. So here's what we need. If the slope of this segment is 4/3 and we're supposed to be perpendicular, we need what the opposite reciprocal of that number. So since we're indicating that this is the slope, what we really care about is the perpendicular slope. So we'll label that like this. The upside down capital T means perpendicular, and M of course means slope, so we're saying the perpendicular slope is going to be -3/4. It's the opposite reciprocal of that number right there. So that green line that I had sketched, it better have a slope of -3/4. Since we're going to bisect this dude, I need to go through the midpoint, so let's find the midpoint of segment AB. Using just these two ordered pairs right here, this is A, this is B. The midpoint's going to be the x's added together over 2, and the y's added together over 2, which is the same thing as 8 over 2 and 14 over 2, which is really the point 4, 7. So let me plot that for you. Boom! I'll call it M for midpoint. That point M right there is the midpoint. Now obviously, since I have a graph, I could go down 3 to the right 4, F4, and I could just take my awesome line right here and connect them together and go boom, there you go, there's the equation, there's the line right there. It's got a slope of negative 3/4 and goes through there, but you don't have a graph, right? I have the luxury of having a graph. If you don't have a graph, you got to do the algebra. So we have a point, right? This midpoint, M right here, is on the blue line. That's the point that we know, and we know its slope should be negative 3/4, so we will use point slope form, sorry, which would be y minus y1, 7, right? That's the point we want to go through, equals the slope of negative 3/4 times x minus 4, right? This is the midpoint right here, and that's our slope. So we'll do some sweet distribution. Y minus 7 equals negative 3/4 x. Then I love when this number right here is a multiple of that number. Negative times negative is a positive. 4 goes into 4 once. Take that times your numerator and you get a 3. And then we'll add 7 to both sides. And we'll get that awesome y-intercept of 0, 10. And you can see that that is the equation of my line right there. It's got a y-intercept of 10. And it's got a slope of negative 3/4. So this blue line is the perpendicular bisector of segment AB. Now let's do it without a picture, right? So follow these steps. Just a warning, these steps will not be provided for you on quizzes and tests, but here today they are. We'll do 5 in a row so we can get them down. We need to find the slope first. So let's do that. Guys, it's important that we take our time and not make a sign error. Because, man, if you get this wrong, you're going to get everything wrong. You know, if you don't have the right slope, the whole problem is just going to be a waste of time, almost. So here's the slope. We really care about the perpendicular slope, which is the opposite reciprocal of that, which is 4 over 1, which we'll just write as 4. But since this guy's going to get bisected, we need the midpoint. So I will find the midpoint of segment AB by adding my x's together and adding my y's together. And be real careful that you don't end up doing like a slope formula here, you know. That would be negative 2 over 2, and that would be 18 over 2. And then that's the same thing as negative 1, 9. Sweet. So I have my point, and I have my slope. The midpoint is the point we want to go through. The perpendicular slope is the slope we want to use. So y minus 9 is 4 times x minus a minus 1, which turned into a plus 1, right? Minus a minus. Distribute the 4. And add 9 to both sides. And this is the equation of the line that would be the perpendicular bisector of segment AB right here. So this one's going to turn out messy. Here's what I'd like you to do. Get the first 3 steps done, right? Find the slope, find the perpendicular slope, and find the midpoint. Why don't you pause the video and get the first 3 steps done? And hopefully you got a midpoint of 9 halves 10, and the slope was 4, 9, so our perpendicular slope is the opposite reciprocal of that. Now, point slope form. Here's our point, here's our slope, so y minus 10 equals the slope, which is negative 9/4 times x minus 9 halves. Ugly. Well, one thing at a time. Let's distribute the negative 9/4. 9/4 times x is definitely that. And they're already both fractions. So sign first, negative times a negative will be positive. And now numerator times numerator over denominator times denominator. That's it, right? Now we got to add 10 to both sides, but we'd really like them to have common denominator, so we'd like to turn this into eighths. Instead of adding 10 to both sides, what if we just add 88ths? This is really the number 10, right? So those go away. Negative 9/4 x plus, they'll have a denominator of 8, and 80 plus 81 is 161. And that is definitely not pretty, but that is the right answer. So just realize one thing at a time. Okay? Why don't you do number 19? Pause that video and get the whole puppy done. So that bad boy came out real nice. Slope of 1, opposite reciprocal of that, which means the perpendicular slope is -1, midpoint -7, -11. Point slope form, subbing in, and y should have turned out to be -1x minus 18. And then finally the last one here is not a pretty one, so let's go do it together. Slope, like I said, triple check that you get the right slope, because man, the whole thing is just a big mess if you don't have the right slope. So opposite reciprocal for our perpendicular slope, midpoint going to be 3 plus 5 over 2, and 8 plus -4 over 2, which is just 8 minus 4. That's going to be 8 over 2, 4 over 2, which is really 4, 2. That's nice. But the slope isn't so nice compared to this point. So y minus 2 equals 1/6 times x minus 4. And not so nice because we don't have this number being a multiple of that number. So, alright, whoop-de-doo, distribute the 1/6, turn that into a fraction, right? It's going to come out negative. A positive times a negative is a negative. And then you get 4 over 6 when you multiply, which reduces to 2/3. So even though we may multiply correctly, don't leave it 4/6, make it be 2/3. Then I want to add 2 to both sides, but I really like that to be in the form of a 3 for a denominator. So what if we add 6/3, right? Changing that into thirds, that's 6/3. So we add 6/3 to both sides. And then -2/3 plus 6/3 is going to turn out to be positive 4/3. So that there is what we did. So here's the homework right here. I want to explain two different sections of it, right? Section 3-4, that's just normal. You'll do these problems. Remember, when you make your graph, use a straight edge, put a scale on all your graphs, all that cool stuff. But this extending 3-4, let me open that up. Let me open the book real quick and show you where that's at. So as you can see, here's your table of contents. You're in chapter 3. Here's lesson 3-4, real easy right here, this lesson 3-4. But extending section 3-4, you'll have some problems from that. That's this. It's a whole separate unit. That's where we're writing the equations of lines of perpendicular bisectors. So you got homework from both sections. Once again, here was that list so you can get a copy down. Let me know if you have any questions, and have a good